scientists believed there might actually be a benefit. Some large-scale eruptions have had a cooling effect, throwing so much gas and ash into the air that sunlight was reflected away from the Earth. But it appears that Chai-10 is throwing the wrong kind of particles into the air. Samples from downwind showed that the eruption was low in sulfur. The smoke and ash of the Chai-10 eruption highlighted an important concern. What threat do these volcanic discharges pose to nearby populations? 7,000 miles away, in Paradise, intrepid scientists decided to try to answer that question. Hawaii's most famous volcano, Kilauea, erupted with a startling blast of gas and ash that forced the evacuation of 2,000 tourists and scientists. Despite the hostile environment, researchers decided it was time to test the noxious air of an erupting volcano at the source. Using sensitive instruments suspended from state-of-the-art balloons, scientists Adam Durant and Matt Watson managed to launch their equipment directly over the volcano's roiling crater.
Yeah, that's fine.
Even wearing protective gear, they could spend only a few minutes at the site. Any longer, and they risked exposure to potentially fatal concentrations of sulfur dioxide gas.
We are definitely going up late now.
The balloons were piloted remotely by satellite link using a flight trajectory visualization system that incorporated Google Earth.
Yeah, they're all on top of the volcanic cloud.
The team retrieved the balloon approximately 64 kilometers from the launch point.
I found it. Yeah.
For the first time, scientists were able to directly measure the evolution of gases being produced by the volcano using a balloon-based system. They found that, even hours after emission, potentially hazardous concentrations of gases could be detected in nearby residential communities downwind from the volcano. But fortunately, the gases dissipate quickly as they move away from the source. Of the world's active volcanoes, Kilauea is a relatively gentle and predictable one. But scientists now know that volcanic time bombs lurk under some of the most beautiful places on Earth, like Yellowstone National Park. Few tourists are aware that the famous spouting geysers only hint at the smoldering monster deep beneath the surface. A supervolcano. Instead of a cone, supervolcanoes have a circular caldera where magma and earth have been sucked inward during an eruption. The last time Yellowstone exploded, some 600,000 years ago. It blanketed half of the US in ash and wiped out thousands of species. Some say it's overdue to go off. But last year, geologists managed to take the volcano's temperature, and it's far cooler than expected. Yellowstone's hot spot of magma may be cut off from its supply at the Earth's core, and we can breathe a sigh of relief. But 2008 was not a year in which many could breathe easier. When the Earth beneath our feet was not shifting and exploding, our seas and skies rampaged. Researchers announced that natural disasters have doubled in the past 2 decades. Is the Earth really becoming more dangerous to its inhabitants? And is it our fault? While debate continued, science took us ever closer to understanding how and why the skies rage. 2008 brought one of the most heartbreaking days in meteorological history. On May 2nd, the devastating winds of Cyclone Nargis stormed ashore and slammed the impoverished nation of Myanmar to its knees. Official reports estimate that nearly 130,000 people perished in the monster storm.
The thing about that part of the world is that there's a lot of very low-lying populations that are very vulnerable. When you get something of that scale coming through, it has that much more damage.
It was one of the most devastating cyclones of all time. The deadly toll of bad weather in 2008 had only begun. Typhoons and their Atlantic cousins, hurricanes, devastated coastlines around the world. Hurricane Ike, the most damaging of the 2008 hurricanes, actually reshaped the coast of Texas, swallowing small islands that once dotted the coastline. But people will continue to build and rebuild in areas that bear the brunt of large storm systems. So scientists at the University of Florida undertook an innovative step in the quest to make homes more resilient to cyclones and hurricanes. In 2008, they put a groundbreaking portable hurricane simulator to the test, pushing the limits of the next generation of building materials and structures. With its 2,800 horsepower, the machine can replicate the 200-kilometer-per-hour winds and rain recorded by the researchers from the heart of recent hurricanes, reproducing them under controlled conditions. So far, they discovered that what may be good for a wood frame wall may be the worst possible choice for a concrete block stucco structure. They're testing a variety of wall and window structures to help scientists and engineers shore up our defenses against future storms. Hurricane research in 2008 wasn't only about their awesome power of destruction. New insights about their unexpected birthplace came from a surprising source, half a world away on the far side of Africa. Continuing research last year found that 90% of Atlantic hurricanes were preceded by lightning storms over the highlands of East Africa in Ethiopia. The chaotic weather that produces the intense lightning interrupts the path of trade winds, fragmenting them into unstable eddies.
The dynamics of this is quite interesting because it seems that the lightning storms create disturbances in the troposphere. And these disturbances can travel a long distance, sort of for thousands of miles. And when they hit the Atlantic, they can be a source for a hurricane development. If we actually see this correlation, we can actually try and predict when a hurricane is coming, maybe 7 or 8 days before it actually starts to fall.
But we've also discovered that the vast interior of Africa may stifle as well as stimulate the birth of killer storms. All that bad weather has to pass over the Sahara, source of the biggest dust storms in the world.
Part of the hurricane formation is caused by the sea temperature rising. But if you have lots of dust in the atmosphere, it reflects more sunlight energy out into space, and so the sea temperature remains lower. So if you have a low temperature and lots of dust in the atmosphere, perhaps hurricanes are less likely to form.
All of that dust also helps fertilize the Atlantic Ocean.